In this presentation, we are going to look at the complement rule when used in probability distributions. In particular, we're going to look at the normal distribution, but this presentation would apply, the rule as we apply it here would actually apply to all continuous probability distributions, but not discrete. Now, just remember, I've put this in with the the normal distribution, so that is why, and the normal distribution is a continuous distribution. So it's a very simple rule for working with probability distributions, but it's also very important. Very simple rule, but very important. Now, just a quick reminder about something. So for continuous probability distributions, including the normal distribution, the probability of an exact value is extremely small, such that we can treat it as if it was negligible, almost zero essentially. So the probability of x being equal to k, where k is some value, x is the name of the random variable, and k is some particular value, the probability of it being exactly that value is extremely small, such that it's almost not worth considering, as not worth bringing into your calculation. So we'll treat it as extremely small, almost zero. So when we're looking at expressions such as this and this, we could treat them as if we can neglect the equality component. So we could just essentially probability of x less than or equal to k is interchangeable with probability of x less than k, and vice versa for the other one. Now, so we can treat these two expressions, the ones I have underlined here, I'll underline them again. That one there and that one there. We can treat them as complementary events, okay? And again, just to re-emphasize it, because the only overlap is the probability of x is equal to k, and it is almost zero, such that we can disregard it. So this is how we might, this is sort of worked example we are going to do. Now essentially, to compute the probability of the complementary event, essentially all we have to do is to subtract from 1. So for both cases is essentially, for the two expressions I presented there previously, it's essentially one is just one minus the other. So the probability of x less than or equal to k is equal to the probability of 1 minus the probability of x greater than or equal to k, and vice versa. So let's look at a quick example there. So we have two expressions here. The probability of x less than or equal to 100 is 0.65. So what's the probability of that being greater than 100? 0.35, which is 1 minus 0.65, 0.35. But likewise, the probability of y greater than or equal to 80 is 40%. What's the probability of y less than or equal to 80? 0.60, 1 minus 0.40. Okay, that ends our presentation. It's short and sweet.